Hi there. So here's question 4 from the practice problems reviews. We want to find the number of pins that have 3 digits. This time repeated digits are allowed, but first digit is not 0 and the second digit is not 9. So we'll use the shortcut method that we've been doing. First, we want to count all the 3-digit pins. We'll call that set U, so the number of things in U is equal to filling in these blanks. The number of options for each blank is 10, because you can use any digit. So we're going to multiply those together, and we get 1,000 possible pin numbers. So then we need to count the number of illegal pin numbers. When we'll count the number of illegal pin numbers, we'll subtract those from the total. So I decided to call A the 3-digit pins with the first digit equaling 0, and set B 3-digit pins with the second digit equaling 9. So I'll count both of those first. So if the first digit is a 0, I'll go ahead and fill it in. But then there's still 10 digits for 10 options for each of the other 2 digits. We're allowed to repeat. And so that would give you 100 for the number of items in A. Same for B. This time I'll fill in that 9, but then there's still 10 options for each of the other 2, and that gives me 100. And then we're interested in the intersection. That's where we have both in the set A and the set B, so both the first digit 0 and the second digit 9, which leaves only 10 more options, or which leaves only 10 total options, because there's only 10 ways to fill in that third digit. Alright, so I'll go ahead and draw a picture of this just as an illustration. Of course, now you know how to find the final answer, since we've done this a few other times. But here's an illustration of it, since we have space on the board. Here's my big set U. And U has all 3-digit pin numbers. And then here's an A and B. So for a couple of examples, A has 3-digit pins with the first digit 0, so things like 0, 3, 0. You're allowed to repeat. B has things with the second digit 9, so things like 1, 9, 7. But the intersection has both the 0 in the first and the 9 in the second, and then anything in the third. So for instance, 0, 9, 9 would be in the intersection, but also any other choice for that third digit. So the ones that we actually wanted to count are the ones that are not in either circle, the ones that are in the complement. So that would be the items that are outside here, things that don't have a 0 in the first spot, don't have a 0 in the second spot, can have, or don't have a 9 in the second spot, but can have anything in the third spot. So you can make lots more examples of those too. So then, remembering the way that we count the stuff that's outside, is what we want to have as our final answer. And in this case, what you can call it is the complement of A union B. And the formula for that, we've written it down several times, would be this number, the whole set U counted, minus A minus B, but then adding back in A intersect B, the number of items in the middle, because we don't want to subtract those twice. So it's, for this problem, 1,000 minus 100 minus 100 plus 10. So we get 810 total possible answers. So that's an interesting comparison to some of the previous ones where we had repeated, this time digits repeated, and in the previous problems we had no repeated digits.